This will also be helpful for anyone who's new. So hopefully you can catch up a little bit. Otherwise, you go and watch the video. But basically what we have already looked at is we've had a look at translations. Now, translations is when we move coordinates or where we move points up, down, left, and right. So that's what I've said over here. So if we are basically sliding a shape somewhere to a new position on my Cartesian plane, that is a translation. So if we have a look at this example here, I've given the instruction that we need to take this quadrilateral ABCD and we need to translate it 4 units up and 7 units left. Now, however you choose to do this is entirely up to you, but what I find the easiest is to count the units that I need to move. Now, if you are more comfortable doing it in 2 separate steps, by all means do that, but you don't have to, you can do it all in one. So when I say 2 separate steps, what I mean by is you can start with the 4 units up. And so we can take point A and we can move it 1, 2, 3, 4 units up. Now that isn't my final position. It still has to be moved left, but now I know sort of where the movement up is going to take me. If you want to do it all in one step, well, you know this has to move 7 units left. So we can go 1, 2, 3, 4, 5, 6, 7. And where I end up after going up and to the left, according to the number of units I've been told to do, is my new coordinate for A. Now remember, we label these coordinates A dash. So there's a little apostrophe that we put there, and that's showing me that my coordinate has been transformed in some way. So we always label it with a little dash. Okay, so if we do the rest of these coordinates, I'm just going to take off my scribbles. B needs to do the same thing. 4 units up, 1, 2, 3, 4, 7 units to the left, 1, 2, 3, 4, 5, 6, 7. Oh, it's a bit of a jump, but anyways. And we get B dash. Take my scribbles off. And we do the same thing for C. Go up 4 units and then left 7 units. And we do the same thing then for D. Okay, so if I move D up 4 units and left 7 units, I get D. Once I've done that, I can use my ruler and I can draw in my lines. I'm not using a ruler, you guys will use a ruler. And we'll draw in the lines to get the quadrilateral that we needed to translate or shift. Okay, so like I say, you guys will use a ruler. But sorry. Oh, excuse me. But essentially our translation is sliding my shape up, down, left, or right. Right, so take a screenshot if you need to. Packard, I don't know if this is your name. You can tell me if it is or isn't. Do you have a question for me? Oh, thanks, guys.
Yes, ma'am.
Yes, tell me.
I'm new to the class, ma'am. My name is Ashley, ma'am. And
Ashley.
Yes, ma'am. My name is Ashley. Ma'am, I'm quite lost, ma'am, because I just came just now, ma'am.
Okay, so this is a recap of what we've already done, and you can find this video of this lesson on Watobe's website, so you can go and watch it there. I'm going to do another example of recapping this, but basically what we have done so far is being able to move shapes up, down, or left or right. And this is an example of that. So we're going to do another example, but otherwise go ahead and watch the video that's on Watobe's website.
Yeah, thank you, ma'am.
Awesome. Cool. Okay, guys. So like I said, this is an example of translations. It's just basically sliding the shape. We're not changing the shape. We're not rotating it, reflecting it, making it bigger, making it smaller. We're literally taking it as it is and we're sliding it along my Cartesian plane. Okay, so take your screenshots if you haven't already, and then let's have a look at another one. I might need to run and get a tissue. Give me 2 seconds. Okay. Right, so let's have a look at a second one. So as I've just said to Ashley, if you are new, don't stress, it's okay. And like I said, this lesson happened on last week sometime. And so the recording will definitely be on Watobe's website now. And so you can go and watch the recording there and hopefully catch up on the stuff that you've missed. Alrighty, so question B is asking me to translate the triangle JFK 2 units down and 3 units right. And of course, I have not given myself enough space. So let's change this. Let's go 2 units up, because otherwise we're not going to have enough space. Okay, so we're going to translate triangle JFK 2 units up and 3 units right. Now again, just take each point and do what it's telling you to do. So let's take point F. We're going to move it 2 units up, and then we need to move it 3 units right. So this new point F is going to be here at a coordinate of -1, -2. And remember, we label it with a dash. All right, I'm just going to take my scribbles off so that I can still see what I'm doing. I'll then go to the next coordinates. So it doesn't really matter what order you do them in. You're going to do all of them anyways. So if we go to K, we want to go 2 units up and 3 units right. So my new coordinate for K is at +1, 0. And we label it K dash. And then finally, I need to do the same thing for J. 2 units up, 1, 2, 3 units right. So the new point for J, so J dash is going to be at the coordinate 3, 0. Then obviously you take your ruler and you draw in your lines, the sides of your triangle. That's a shocking line. Didn't get any better, but it's all right. And what we've now done is we have moved the triangle JFK up 2 units and to the right 3 units. Now, as you do more and more of these, you will get more comfortable with it. But essentially, that's all it is. It's taking the coordinate and moving it according to the instructions that you've been told to move it. Okay. So like I say, this is what we have already covered, and the video is on Watobe's website so that you are more than welcome to go and watch it. Can I just get a sort of thumbs up, thumbs down that we're okay with translations? Because we are going to have a look at a new type of transformation today, which is quite exciting. You can use the reaction button, you can put it in the chat. Really up to you.
Yes, my people, let's go. There we go. Let's do those votes like this. Teacher Sam can see. It looks like everyone. Well, so far, whoever voted, everybody understand. We are on the same page. Please don't feel pressurized if you don't understand. We are here. Amahle is asking if you could please do one more. Amahle, like Teacher Sam has explained, there is a video that we already, a lesson that we already did last week. So, and I believe that somehow, some way, we will definitely come and revise this again, right, Teacher Sam?
No, we definitely will come back and revise everything that we've done in this course. But I would recommend that you go and have a look at the video for the whole lesson on this. But like I said, we will come back. I think it's in our last lesson in this course. So it'll be next week, Wednesday, where we will revise everything that we've done again. Okay, so this isn't going to be the last time we touch on translations.
Kabang, do you have anything to ask Teacher Sam? I'm unmuting you.
No, ma'am, I don't have anything to say. I also just wanted to ask where we could find the video for the last lesson, so I can rewatch it.
It's definitely on the Watobe website. So when you log in with your login details to Watobe website, you can navigate through there and you will find it.
Okay.
So it should all be like under the grade 8 lessons, I think. It's something like that. It's under the grade 8 videos. It'll all be there, and it should be under the heading transformation geometry.
Okay, thank you.
Pleasure. Okay, so guys, just to sort of like rehash this or recap this. Oh God, we have done this lesson already, so please do go and watch the video if you're feeling a bit confused. Basically, what we have already spoken about is the fact that we can move coordinates or we can move shapes on a Cartesian plane up, down, left, and right. So this sort of shape, we went from the blue shape and we moved it up and to the left according to the instructions given to me, forming my new shape A dash, B dash, C dash, D dash. And then in the second example, very similar thing. We were given instructions of how to move the shape. We had to move it up and then to the right. And so we did that with every single individual point. We did that movement, 2 up, 3 right. And we did that for F, K, and J, and we got our new coordinates. Okay, so what we're going to have a look at today is we are going to have a look at reflections. Okay, so this is where stuff starts becoming quite fun. Now, these first two transformations, the translations, the moving up and down, then the left and the right, and the reflections is going to be super important in sections to come. So when you get to like grade 10 and you start doing graphs and functions, these concepts are going to be really important. And this is why I've said to you, it's so important that we feel comfortable with this stuff and we practice this stuff as much as possible. Okay, so I thought I had a video here, but it could be crazy. It's entirely possible. Alrighty, so we're going to have a look at reflections here. Now, if you think about the word reflection, we think of like a mirror, right? If you look at yourself in the mirror, you're just looking at a reflection of yourself. And so what we need to remember is that in geometry, it's a very similar thing. It's basically if we held a mirror up at a very specific point, we would see the reflection of a shape. Okay, now what is super important when we do reflections is firstly, we need to know which line of reflection we are working with. So if I just make this a tad bigger, there is something or there is a phrase that will come up here called the line of reflection. And that is basically which line are you reflecting the shape over. This will make a little bit more sense in a second or two. And the other important thing is what you need to remember. And again, if you think about a reflection in a mirror, you're always going to be the same distance away from the mirror as your reflection is. Now, I don't know if that makes much sense, but basically, if you stuck your face right against the mirror, your reflection is going to be super, super close. If you stood way far back from a mirror, your reflection is also going to be quite far back. And so the same distance needs to occur between your reflections. So if we have a look at these two diagrams that I've got here, these are examples of reflection. Now, what you need to imagine is this line of reflection that I was talking about. Okay, now, if I look at this very first diagram, so let's start here with the star, and I look at the shapes that I've been given, I can see that the line of reflection, so basically if you imagine me holding a mirror along the x-axis, that would create this mirror image of triangle ABC to triangle A dash, B dash, C dash. So the line of reflection, you can almost imagine as your mirror. And that is the point on your Cartesian plane where the mirror would be, and it would create the reflection for you. Okay, now, when I spoke about the distance of your reflection, if we go and have a look at, you can look at any points, but I'm just going to choose point A. We can see that the coordinate A, so the original coordinates of the blue triangle, is 4 units away from my line of reflection. And that needs to be the same on the other side. So now if I count 1, 2, 3, 4, it is also 4 units away from my line of reflection. And that's because a reflection shouldn't distort. It's not like one of those weird mirrors at like a carnival, or like those like mirrors that like make you look all like distorted. It has to be a perfect reflection. So the distance between your line of reflection and your points needs to be the same. Okay, can I just get a thumbs up, thumbs down if we're feeling okay with this before I move on to the next explanation? because I know this is quite hard to visualize sort of just without anything in front of you. If you're going to give a thumbs down, that's absolutely fine. If you have maybe specific questions that you can try and ask, that'd be really cool. I can see some half up, half down, which is also okay. No problem at all. I want to see if I can maybe find something that will help us. Okay. All right, guys. So let's see if this maybe helps. I thought I had this link in my lesson plan, but I did not.
I'm just telling everybody that we'll do much more examples. So it's okay for you to feel a little bit confused because it was only just one example. So y'all are going to be fine, and we appreciate your votes. And guys, by the end of today's lesson, because I'm aware that Teacher Sam will teach us this again and again. So y'all are gonna be fine, okay? And please do ask questions. So for now, I think Teacher Sam will just try and explain something. Well, we have something to watch. So let's listen, peeps.
Right, guys, I'm not going to play the whole video because it's just not necessary, but hopefully seeing this will make a little bit more sense. I'm assuming we can all see my screen, so let's see how we go.
Movement or change in a geometric shape. Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the
Teacher Sam, so the sound is very low. We couldn't hear any sound.
Let's try again. Guys, we're all learning here. It's okay. Is this better?
reflection is a type of movement.
Yes, now we can hear.
Think about when you look in a mirror. You see a reflection of yourself. See how your reflection appears to be the same distance from the surface of the mirror as you are? Also note how the left and right sides are reversed. The same is true with geometric shapes. When we reflect this triangle like this, the x-axis acts like a mirror. You can reflect all kinds of shapes as long as you determine the line that you want to reflect on, just like a mirror. For example, you can use any line along the x-axis or the y-axis. You can even reflect a shape through a line using an expression such as x.
Okay, so I'm going to pause it there just because the next little bit isn't too important, but hopefully what we can see is that by reflecting, I'm creating a mirror image. That's basically all a reflection is. I'm creating a mirror image of my shape. Okay, now guys, like Yolanda says, we're going to go through lots of examples and we're going to see what's happening here. But that was hopefully just to give you a bit of an idea of what a reflection is. Now, in the video, they said we can use any line along the X and the Y axis, and this is true. If we go to the second diagram over here, I can see that my mirror image has been created over the Y axis. I've gone from the green triangle to the blue triangle. And so my Y axis over here, obviously I'm highlighting this very well, forms my line of reflection. So that is acting as like my mirror to create this mirror image of my triangle. Okay, now I know that this is hard to visualize, so don't stress if this doesn't make sense like immediately. It's absolutely fine. We're going to do examples and hopefully it'll make more sense. But just remember, guys, you can go back and watch this video and we are going to do more work on this. All right, so don't stress too much about it. So let's get into some examples. So hopefully we can try and make sense of what these reflections are saying to me. So like I say, one of the most important things to know when doing reflections is which line are you reflecting over. Now, generally, we will use the X or the Y axis, okay, as our line of reflection. So let's just start with this very first one that tells me to reflect triangle ABC, which is the blue triangle I've given you here, over the x-axis. Now, before we even start, so don't even worry about the reflection just yet, I want to get the coordinates of A, B, and C. So maybe someone wants to raise their hand if you would like to give me the coordinates of A, of B, or C, or you're welcome to pop them in the chat. But if someone could give me the coordinates of A, B, and C. Remember, coordinates, we read off the X first and then the Y. Anyone want to give it a go? Wangi, tell me, would you have a question?
Hi, ma'am.
Hi.
I said A is 11.
Good.
A dash is 11 and -4.
Okay, I don't want A dash just yet. I just want the original A.
Oh, the original one is 11 and 4.
Good. Okay, sorry guys, I don't think I made that very clear. I want the original coordinates first. We will get to the reflected coordinates in a second. Thank you, Wangi, for making me clarify that.
Okay. Ma'am, should I carry on?
We've got some other hands, so I'm going to ask some other people, but I'll come back to more questions. So definitely raise your hand just now, okay?
Okay, ma'am. Thank you.
Thank you. Okay, Bonganele, do you want to tell me what the original B coordinate was?
I'm not sure if I'm right, but I think it's 5-3, ma'am.
Excellent.
Thank you,
Okay,
ma'am.
so B is 5-3. Awesome, well done. Amahle, do you want to give us C?
I think C is 3-4.
Excellent, well done. Okay, guys, so those are the original coordinates of my blue triangle. So now we want to reflect it. It very specifically told me that I need to reflect this triangle over the x-axis. So I need to identify where my x-axis is. Remember, it's the horizontal axis. And that's going to be my line that acts as a mirror. Now, obviously, it would be really cool if we could just put a mirror there and see where the reflection ends up. But we can't. We now need to figure out what happens. So I can see that if I'm going to reflect this triangle over my x-axis, it now needs to end up underneath my x-axis. I also need to remember that the points need to be the same distance away from my line of reflection. So basically, if I start with A is 4 units away from my line of reflection, which means that my new coordinate for A, and maybe let me get a different color, needs to be 1, 2, 3, 4 units away. And so this is why earlier Wangi gave me a coordinate of A dash of 11, -4. Because now, it's sitting on the underside or the opposite side of my x-axis. And so this is where A dash ends up. It's not a very good dash. Okay, the hands that are up are these hands for question. No, let me not phrase it like that. Can you leave your hand up if you would like to give me the coordinates of B dash and C dash? If you have a question, I will get to questions in a second. Okay, Nompulelo, do you have, or do you want to give me B dash? Oh, Nompulelo, I'm so sorry.
Ma'am?
Yes.
No, I just wanted to ask a question.
Yes, okay.
Ma'am, I want to know, I don't understand anything because I got in class late.
Okay, so I think what you need to then do is carry on listening to the examples because we're going to do quite a few more. But if you're still not understanding, you need to go and watch the video on the website when it gets uploaded. Okay.
Yes, ma'am.
Cool. Alrighty. Tiamo, do you want to give me B dash?
Hi, ma'am.
Hi.
B is 5 and -3.
Excellent. Okay. So B dash, we can see it's 3 units away from my x-axis. So it needs to be the same on the other side. So B dash is going to be at 5, -3. Well done. Right. Mbali, do you want to give me C dash?
Yes, ma'am. C dash is 3 -4.
Excellent. So C dash is at 3 -4. Good. Well done. Okay, guys. So once we know where all of our coordinates are, we can draw in our lines. I'm going to try drawing straight lines. I don't know if it's going to be very successful, but let's see how we go. So you take your ruler and you draw in your lines to join the coordinates that you're forming your new triangle A dash B dash C dash. Because remember, the whole instruction was to reflect the triangle. It wasn't just to move the points, you had to do the whole triangle. My lines are a bit dodgy, but it's all right. We move. Fine. No, it's fighting me. I'm just going to draw it freehand. It's not going to be perfect, but it's fine. Okay, so we have got our triangle A dash B dash C dash, and we have written down the coordinates on the side in red. Emildine, I hope I'm saying your name right firstly, and if I'm not, please feel free to correct me. It does matter what order we write the numbers in. It is very important that we always write the X first and then the Y. That is the order our coordinates must be written in. If we mix it up, then we're talking about a completely different point. So X first and then the Y coordinate, okay? Okay, guys, so let me just see. Bali, do you have a question?
No, ma'am, sorry, I didn't lower down my head.
No problem. Okay, guys, so I'm going to ask you a question now, and you're welcome to raise your hand to answer if you'd like to, but otherwise just think about it as we head into our next example. So my question to you is, actually, we're going to take a little break. So let me ask my question. You can think about it. I'll ask for answers afterwards. Do you notice any sort of pattern that has come about from the original coordinates to my new coordinates? So if you want, you could more than welcome to take a screenshot of the screen, but I want you to think about that for a second. And then after we've had our little break now, I'm going to ask you the same question again, and then I'm going to ask for some answers. If you're not seeing a pattern yet, don't stress. We're going to chat about it. Right, I'm assuming everyone's taking a screenshot. I'll leave it for 10 seconds, otherwise I'm moving. Okay. So this is our brain break for the day. Rotile, I'm assuming that hand is up to answer my question. So just keep it in the back of your head. We'll come back to the question now. If it isn't, please do pop your message on the chat. For everyone asking me to repeat the question, my question is, do you notice a pattern or some sort of relationship that's happening from the original blue coordinates to the red coordinates? Okay.
We have our break, my babes. Y'all are doing great. I'm here and I'm like, yes, my people.
Okay, guys, nice. So our break's a little bit different for the day. It's not really very mathy. It's what was my words have escaped me. It's like those guess the phrase ones. Hoping I remember all of them. I already see some hands, and I already see Tsepi's put an answer for 6, which is awesome. So have a look at them, and then you're welcome to raise a hand or pop it in the chat to tell me what the phrase is. I just need to blow my nose, so I need to mute myself. Okay, Ortile, do you have something for us? Okay. Nadia, do you want to give us one?
Hello, ma'am.
Hi.
Ma'am, for number 2, I think it's fast food.
Well
Fast
done.
foods. And for number 5, I think it's heat waves.
Good. Well done. This would help if I could spell food, hey? Okay, so guys, number 2 is fast food, and number 5 is
How did you know that?
heat wave.
Oh my word. Well done.
Nice. Well done, Nadia. Seatlid, what do you want to tell me?
Oh, ma'am, for number 6, I think is pie chart.
Excellent. 6 is pie charts. Well done. Anyone want to try guess the other ones? Oh, I don't know if I remember what number 4 was. I don't remember now. I'll give you a hint. For number 4, maybe you don't read it left to right. Saying, what do you want to tell me?
Ma'am, I think number 1 is a mountain.
Okay, good. And how many mountains are there?
2.
2. So this would be Twin Peaks. Well done. Okay. Lita, what do you want to tell me? Lita, can you hear us? I know. Okay. Nkulumo, tell me one. We've got 3 and 4 left.
Ma'am, number 4 is welcome.
Okay. Now, how did you know it was welcome? What did you need to do?
I took the hint that you said, and you said you mustn't read it from left to right.
So you read it backwards?
Yes, ma'am.
Well done. So number 4 is welcome back. Because it's backwards. Well done, Kumo. Okay. Yolisa, are you going to give me number 3?
Oh, I think number 3 is see you.
Well done. Now, what sort of shape is the thing forming?
A circle.
Okay, so this is see you around. So it's around a circle. Well done. Okay, guys. So remember, these little brain breaks aren't like for anything. It's just to take a little break from what we're doing before we move on with the math. So some of those were quite tricky. Well done on getting them. I will be honest, luckily you got them because I'd forgotten some of them already. So well done. Okay, let us carry on with our reflections. Now, I just saw in the chat someone asking how to take a screenshot. It's going to depend very much on your device. If you are really struggling, maybe just take a photo of your screen so that you have it there. So what I'll do is I'll just do that so that you can still see the first example. And then, yeah, it's going to depend on your device, how you take a screenshot. Okay, so guys, I had asked before we went into our brain break, do you notice a pattern? And if you don't, that's cool. We're going to do more examples and hopefully we'll eventually see it. But that was my question. So I can already see quite a few hands up, which is awesome. Let's see. Oh, okay, Bontle, what pattern do you think you see?
Ma'am, for the first, the picture that they gave us, the second coordinates are positives. Then for the second picture, the second coordinates next to the first ones are negatives of the first one.
Okay, so what Bontle has seen here, and I'm just going to sort of highlight as we go along, if we go to the original coordinates, so the original coordinates were the ones in blue, okay? And we look specifically at the y coordinates, so the second number. All of those were positive. But now all of a sudden, when I go to the red coordinates, they're the same numbers, but they're negative. And so this is some sort of relationship that we're seeing. Okay, I can see some of you on your chat, on the chat as well. Y is staying, X is staying exactly the same, but Y is changing. And so the question is, why does this happen? Well, let's think about this. I'm just going to zoom into this one here for a second. My line of reflection was over the X axis. So if I'm thinking about it and I'm sitting on top of the X axis, do we all agree that when we're sitting above the X axis, all of the Y coordinates are positive because I'm above the X axis? However, the second I flip below the X axis, so that reflection, and I end up below the X axis, now I'm moving to a situation where all of my Y's are negative. And that's because I've gone over the X axis. I've gone to where it's positive over to now where Y is negative. Okay, now these things will start to become like more familiar as we do more examples, but this is one of the important things that we need to see as we start to reflect. So what I'm going to do is I'm going to write a little note here. It's not going to be my neatest handwriting, but it'll be fine. The Y coordinates, when we go over the X axis, oh, I told you it's not going to be neat. Coordinates change their sign. So if they were positive, they become negative, and the same thing the other way. If they were negative, they'll become positive. And that's because we're going above and below the X axis. So the Y signs change. Okay. So let's have a look at another example, although before I move on. Yolisa, do you have a question?
Yolisa, you have to unmute on your side.
I've just seen in the
try
chat.
to find, yeah, there we go.
Okay, no problem, Yolisa. I'm going to lower your hand, but obviously if you have a question, you're welcome to ask when you do have one. Or Atile, do you have a question?
Hi, ma'am.
Hi.
Ma'am, I wanted to ask, will the second coordinates stay the same? Like, will it be the way the pattern it was here, ma'am? Like, will +4 become -4?
Yeah, so whenever we're going over the X axis, so that's very important. Whenever we reflect over the X axis, then the Y coordinates change their sign. So like we've seen here, it went from all positive to all negative. Does that make sense?
Okay, thank you, ma'am.
Okay, good. Well done. Good.
Thank you.
All right, guys. So importantly, the numbers are staying the same. The numbers aren't changing. It's just the sign that's changing when we reflect over the X axis. Okay, so let's have a look at another example. So this question is telling me to reflect the triangle ABC over the Y axis. So now I have to be careful. My Y axis is this vertical axis over here. So this purpley pinky one that I'm highlighting. So now the shape is currently on the right-hand side, but I want to flip it over to now be on the left-hand side. So I somehow need to take it from the right and flip it over to the left. Now, we do it the same way as what we did the last one. I know that all of the points must be the same distance away. So C, I can see is 3 units away on the right-hand side. So it must be 3 units away on the left-hand side. So C dash is going to end up at my coordinate -3, 4. And I'm going to write that down for us. -3, 4. Whereas the original C, so of the blue triangle, the original C was at positive 3, 4. Okay, does someone want to tell me where the new coordinate of A is going to end up? So where A dash is going to be if I'm taking A and reflecting it over the y-axis. Okay, Mbali, do you want to tell me?
Ma'am, it's going to be 4-11.
Sorry, say that again. I missed the first part.
Ma'am, it will be 4-11.
Okay, so remember for the original A. So this A here is definitely, whoops, daisies. Remember 11 comes first because X first. So 11, 4. So where's the new one going to be in Bali?
The new one will be -6, 4.
Why -6?
Because ma'am, the y and the new y will be under -6.
Okay, so let's just have a look again. What we want to be doing is we want to take this A and we want to reflect it or create its mirror image over the purple line. So I can see that A is 11 units away from the purple line. My hops are getting a bit weird. So it has to be 11 units away on the other side as well. So if I now move it to those 11 units, I can see that A dash is now going to be here at -11, 4, because I flipped it over the purple line. Would you agree?
Yes, ma'am. I didn't understand.
No, that's okay. We got there. Well done. And thank you for giving me the original coordinate because I'd actually forgotten about that. So well done for doing that.
Yes, ma'am.
Okay, so guys, A dash is going to end up at -11, 4. And now because I've been reminded to do it, Bunganele, do you want to give me the original B coordinates and then B dash's coordinates? So the original and the new coordinates.
I think the original one would be -3 and 6.
Okay, wait, hang on. Which coordinate comes first, X or Y?
Oh man, sorry, ma'am. Would it be 5? Would it be 5 and -3, ma'am?
Good. And the new one?
It would be -3 and 5, ma'am.
Okay, which one comes first, the -5 or the -3?
Oh ma'am, the -5, ma'am. Sorry, ma'am. You're confused.
That's all right. There's a lot of negatives going on here. Right. Well done. Exactly. So my new coordinate for B is going to be at -5, 3. And this makes sense. That's 5 units away. And that's 5 units away. They are the same distance away from my line of reflection. And so now when I draw in my triangle, obviously you will do it nicely with a ruler. We can see that we have taken the blue triangle and flipped it over to the left-hand side of my Cartesian plane to form the orange triangle. Okay. Bontle, do you have a question?
I'm sorry, I forgot to lower my hand.
No problem. Okay, guys. So what we've seen is we've got our reflection. So we've taken the blue one and we flipped it over to create the orange one. And we've written down our coordinates. So I'm going to ask you the same question. Do you notice a pattern or something that's happening with my coordinates from the blue to the orange triangle? And you can raise your hand, you can pop it in the chat, but do you notice anything that's happening? Okay, if I mispronounce your name, you're welcome to correct me. Tafara. Can you hear me?
Hello, Tafara. Tafara, we cannot hear you. So I think what you need to do is just to put it on the chat, okay? I think it might be headphones, it might be network.
I appreciate you raising your hand though, thank you. My question is similar to the first question that I asked in question A. Or okay. Ortile, do you want to tell us something that you're noticing? Ortile, you there?
Ma'am, all x coordinates change to negative.
Okay, well done. Ortile, you're a bit what's the word I'm looking for? Your signal wasn't great there, but I got it in the end. Well done.
Yes, ma'am. I was saying that all the x coordinates have changed into the y coordinates.
Okay, so
Can
I'm
you
gonna
hear me, ma'am?
Yeah, no, I can hear you. I thought you had said something different. So let's have a look at our x coordinates because I definitely think something's happening to the x's. Guys, do we all agree that all of these x's were originally positive?
Yes, sorry, ma'am.
Okay, so Tandor's given me a yes, so I'm going to take a yes as we agree that all of my x coordinates were originally positive. Now, if I go to my new coordinates, do we agree that the numbers are the same, but now they're negative? So instead of a positive 11, I've got a negative 11. Instead of a positive 5, I've got a negative 5, etc., etc. Now, this makes sense because I'm taking my blue triangle from the right-hand side of my Cartesian plane, where all of my x's are positive, and I'm moving it over to the left-hand side of my Cartesian plane, where all of my x's are negative. And so it makes sense that they have to go from a positive to a negative because I'm changing where it's going to sit on the Cartesian plane. And so now we can see that whenever I reflect over the y-axis, the x coordinates will change their sign. So we can put a little note here. X coordinates will change sign. And the reason is because I'm going from where it was positive x to now on the left-hand side where it is negative x. So I'll leave that up there for a second while I answer Ashley's question.
Ma'am, I just wanted to ask, ma'am, may you please repeat what you just said, ma'am, so I can get it down because
okay,
taking
no
notes.
problem. No problem. Okay, so guys, I'm going to say it again. When we reflect over the y-axis, so this line, this vertical purple line down the middle, what happens is that the x coordinates will change their sign. And this is because I'm moving from a place where it either was positive to a place where it is negative, like in this example, or I could go from where it is negative to where it is positive. Okay, and so what happens when I reflect over the y-axis is now the x coordinates change their sign. So we had two situations. I'm just going to make that a bit smaller. We had our first situation where we reflected over the x-axis. So we went from above the x-axis to below. And so the y coordinates were changing their signs. But now when I'm going from the right to the left or the other way around, it doesn't matter. My x coordinates are changing their sign when I reflect over the y-axis. Okay, now I know this is a lot of new stuff, so please don't stress. We will do more examples like this. And it's a lot of information to try and get in 1 hour. So we're definitely going to do more examples. But what you need to get in, like, sort of start coming to terms with is the fact that these coordinates change in a very specific way according to which line we're going to reflect over. Right, so I will leave this up in case you want to take a screenshot just to remind yourself, or in case you want to take any notes. And we will do a little recap of this before we start with the new stuff on Wednesday, okay?